Hello friends, I am Pramod. Today we will discuss about the Legendre's differential equation. So what do you mean by Legendre's differential equation? Okay, consider third order differential equation, that is a0 ax plus b का whole cube dqy by dx cube, a1 ax plus b का whole square d square y by dx square plus a2 ax plus b dy by dx plus a3 y equals to f of x. Okay, so this is 3 and this is what dqy upon dx cube. But this is third order differential equation. So that type of differential equation is known as the Legendre's differential equation. But till today you know how to solve the linear differential equation. But that Legendre differential equation you will convert in the form of a linear differential equation, and thereafter by you will solve to find the PI, general method or shortcut method or the method of variation of parameter. Okay, so here you will convert the Legendre's into a linear differential equation. For this one you will replace ax plus b dy by dx, ax plus b ka whole square d square by dx square, and x plus b ka whole cube dqy by dx cube. For this one you will, that is what you will let put x plus b, or that is put, not let, put ax plus b equals to e raised to z, taking logarithm both sides, log of ax plus b equals to log of e raised to z equals to z. That means so z equals to log of ax plus b. This is the value of z. Okay, now you will find the value of ax plus b into dy by dx. So you know that dy by dx you can write dy by dz into dz by dx. Okay, you can write, so by the cancellation of dz and dz you will get the value of dy by dx. Okay, so what is the value of dz by dx? You will differentiate z with respect to x. So this is dy by dz into z, differentiate z with respect to x. So that is the derivative log of x plus b, matlab 1 upon x plus b, and x plus b ka a and b is constant 0. Okay, so this is dy by dz into a upon ax plus b. Okay, तो हमको क्या चाहिए, ax plus b into dy by dx. So ax plus b you bring in the left side. So this is x plus b dy by dx equals to a dy by dz. So this is a, this is what, a dy, where d by dz equals to capital D, because here the x is converted in the form of z. So in case of x, so d by dx equal to capital D, but here the function x is converted in the form of function of z. So here d by dz equals to capital D. So that is a into dy by dz. So d by dz equal to capital D, so a dy. So similarly you can find x plus b ka whole square d square by dx square, x plus b ka whole square d square y by d square, that is a square d into d minus 1 into y. दो टर्म आएगा, इधर हमारा 2 है तो इधर हमारा 2 टर्म आएगा. Similarly x plus b का whole cube dqy by dx cube. So this is a cube d into d minus 1 d minus 2 into y. So in this way, based upon the particular expression, you will find the value of this one, because So based upon a dy, similarly you can able to find a square d into d minus 1 into y, d square a, order is 2, similar order is 3, a cube d into d minus 1, d minus 2 into y, and so on. Okay, so just you will replace this by this, you will replace this by this, and you replace this by this one. Okay, then the Legendre differential equation, it will convert in the form of a linear differential equation, and thereafter you will solve the problems. Okay, based upon the Legendre it will be converted in the form of linear, and thereafter you will solve the linear differential equation. So now you will solve the various types of problem based upon the Legendre's differential equation. Now we will solve the various types of problem based upon the Legendre differential equation, because it is in the form of ax plus b का whole square, ax plus b, तो मतलब it is in the form of Legendre differential equation. So this one you will convert in the form of a linear differential equation, and thereafter you will solve it. Okay, solution. Okay, the put 2x plus 1 equals to e raised to z, taking logarithm both side, take log both side. So this is log of 2x plus 1 equals to log of e raised to z equals to z. Okay, so z equals to log of 2x plus 1, z क्या वैल्यू आ गया. बट इधर व्हाट इज द वैल्यू ऑफ x, इधर हमारा 6x है ना, तो when you will convert x in the form of z, you will replace by x in the form of z. So x equals to 2x equals to e raised to z minus 1, e raised to z minus 1 upon 2. So this is the value of x. Okay, to convert the Legendre's into linear, so this one you will replace and this one you will replace. Okay, so this is 2x plus 1 dy by dx equals to a dy, मतलब 2 into dy. तो 2x plus 1 का whole square d square y by dx square, based upon the formula I told in the definition, that is a square मतलब 2 square, that is 4 d into d minus 1 into y. So this one you will replace it, put this one in the question, that is, so this is 4 d into d minus 1 into y minus 2 into 2 dy minus 12y equals to 6x. X means e raised to z minus 1 by 2, a 3 ja. So this is 3 e raised to z minus 1. Okay, so this is y and y will be common, 4 into d. So this is 4d square minus 4d minus 4d minus 12 into y equals to 3 into e raised to z minus 1. So this is 4d square minus 8d minus 12 into y equals to 3 into e raised to z minus 1. Okay, so 4 will be common, so d square minus 2d minus 3 into y equals to 3 by 4 e raised to z minus 1. So this is in the form of linear differential equation. This is f of d into y equals to f of z, which is linear differential equation. Okay, so now you will find out the complementary function and particular integral, the auxiliary equation. F of d equals to 0. So this is d square minus 2d minus 3 equals to 0. D square minus 3d plus d and minus 3 equals to 0. So d will be common, d minus 3. ये minus 3d plus d equals minus 2d minus 3d square बराबर है. तो d will be common, d minus 3 plus 1 will be common and d minus 3 equals to 0. Okay, so this is d plus 1 and d minus 3 equals to 0. So d equals to minus 1 and 3. So now x plus 1, at last this one you will put, okay. So this is, so what is your CF? So CF equals to C1 e raised to minus z plus C2 e raised to 3z, okay. So that is, then what is the Pi? Pi equals to 1 upon f of d into f of z, मतलब f of x था, इधर हमारा f of z है. So this is 1 upon d square minus 2d minus 3 into 3 by 4 e raised to z minus 1, okay. So this one we will clean now, okay. तो हमारा क्या था, 2x plus 1 equals to e raised to z. So based upon this one you will evaluate, okay. So 1 upon d square minus 2d minus 3, okay. So this is 3 by 4 you take outside. So 1 upon d square minus 2d minus 3 e raised to z minus 1 upon d square minus 2d minus 3, okay. So this is 3 by 4, you put type first, a equal to 1. So this is what, 1 upon 1 minus 2 minus 3 e raised to z, and for constant d equal to 0. So this is minus 1 upon minus 3. So this is 3 by 4 e raised to z upon minus 5. This is what, minus 4, and this is plus 1 by 3. So this is 3 e raised to z upon minus 16 plus 1 upon 4, okay. So now you will replace, because what is the value of total solution? Y equals to CF plus Pi. So CF plus Pi. So what is the CF? C1 e raised to minus z plus C2 e raised to 3z minus 3 upon 16 e raised to z plus 1 by 4. Because the solution, it is came in the form of z. So that z you will convert in the form of x. So this is e raised to z equals to 2x plus 1. Okay. So this is C1 e raised to minus z. मतलब C1 2x plus 1 raised to minus 1 plus C2 2x plus 1 का cube minus 3 by 16. What is the value of e raised to z? E raised to z. E raised to z is what? 2x plus 1 plus 1 by 4. Okay. So this is 2x plus 1 raised to minus 1. मतलब C1 upon 2x plus 1 also you can write. Okay. So in this way you will solve the various types of problem based upon the Legendre's. You will convert in the form of a linear differential equation, and thereafter you will find the CF and Pi. The CF and Pi you will get in the form of z. The z you will convert in the form of x, because our question is in the form of x. So in this way you will solve the various types of problem based upon the Legendre differential equations. Okay. So now we will solve the next problem, that is 3x plus 2 का whole square d square by dx square plus 3 into 3x plus 2 dy by dx minus 36y equal to 3x square plus 4x plus 1, because it is in the form of ax plus b dy by dx. मतलब it is Legendre differential equation. So this one you will convert in the form of a linear differential equation. Okay. So this type of questions is very important. Okay. So that is put 3x plus 2 equals to e raised to z, taking logarithm both side, that is log of 3x plus 2 equals to log of e raised to z equals to z. मतलब what is the value of z? So z equals to log of 3x plus 2. Okay. And what is the value of x is here? X equals to e raised to z minus 2 by 3. So this one will be used to put here. Okay. So now you will directly put the formula ax plus b का whole square, a square d into d minus 1 into y, ax plus b dy by dx. This is a dy, मतलब 3dy. Okay. So you will put directly the formulas. बोलो ax plus b का whole square d square y by dx square, मतलब a square, मतलब 9d into d minus 1 into y plus 3 into ax plus b dy by dx मतलब a dy मतलब 3 into 3dy minus 36y equals to 3x square x मतलब e raised to z minus 2 का होल स्क्वायर अपॉन 9 x square plus 4 e raised to z minus 2 upon 3 and this is plus 1. So this is 9d square minus 9d plus 9d minus 36 into y equals 3 cancel. So this is LCM is 3. This is e raised to 2z a square plus b square minus 4 ab minus 4 e raised to z. This is plus 4 e raised to z. This is minus 8 and this is plus 3. This is a minus b का whole square है. A square plus b square minus 2 into 2 4 into e raised to z. So minus 4 e raised to z plus 4 e that is cancelled. Okay, so this is plus 9d minus 9d. So this is 9d square minus 36 into y equals to e raised to 2z. ये plus 4 minus 8 minus 4 plus 3 minus 1 upon 3. So this is 9 will be common. So this is d square minus 4 into y equals to e raised to 2z minus 1 upon 27. Okay, so this is known as the linear differential equation. Okay, which is LDE. So now you will find the CF and PI. Okay, so this is what is auxiliary equation? F of d equals to 0. So this is d square minus 4 equals to 0, d square equals to 4 and d equals to plus or minus 2. So what is the value of CF? So CF equals to C1 e raised to 2z plus C2 e raised to minus 2z. Okay, so now you will find the PI. Okay, to find the PI, so this is 3x plus 2. So 3x plus 2 equals to e raised to z. So this one we need. Okay, so now you will find the PI. Okay, for PI, that is PI equals to 1 upon f of d into f of z. So this is 1 upon d square minus 4 into e raised to 2z minus 1 upon 27. So 1 upon 27 constant you take outside. So this is 1 upon d square minus 4 e raised to 2z minus 1 upon d square minus 4. Okay, so this is 1 upon 27. ये हमारा टाइप फर्स्ट है. तो टाइप फर्स्ट d equals to a. तो 2 square 4 minus 4 it is 0. You can't able to put. So this is x upon मतलब z upon. This is 2d and this is constant. For constant you will put d equal to 0. ये 0 हो गया, ये minus minus plus हो गया. So this is into e raised to 2z. So this is 1 upon 27 z by 2 1 upon d. 1 upon d मतलब integration of e raised to 2z. e raised to 2z upon 2 e raised to x upon a plus 1 upon 4. तो 1 upon 4 you take ये 2 to 4 है, ये भी 4 है, तो 4 you 1 upon 4 take with common, that is. So this is 1 upon 108. So z e raised to 2z plus 1. So this is our PI. So this is our CF and this is our PI. So that is, so this is CF and this is PI. So this is y equals to CF plus PI. So what is CF? C1 e raised to 2z plus C2 e raised to minus 2z. What is PI? So this is 1 upon 108. So z e raised to 2z plus 1. Okay. So this is 3x plus 2 equals to e raised to z. So this is taking logarithm both, that is, so log of 3x plus 2 equals to z. So this is plus 2 equal to e raised to z, and taking logarithm both side, log of e raised to z equals to z and log of 3x plus 2. So that we will replace. So this is c1 e raised to 2z. So e raised to z equal to this one, e raised to 2z means 3x plus 2 ka whole square. So this is 3x plus 2 ka whole square plus c2 3x plus 2 raised to minus 2 plus 1 upon 108. Z means log of 3x plus 2, e raised to 2z means 3x plus 2 ka whole square plus 1. So this is the final answer. Okay, so in this way you will solve the Legendre differential equation by converting the linear, and thereafter you will find the CF and PI. Okay, so thank you. In this way you will solve the various types of problem based upon the Legendre differential equation. Thank you.